Alright, we're going to do a little 7.6. Thanks a bunch, Mr. Ernst, for that one. I blame him. If you see him in the halls, tell him, come on, bro. Natural logs and E. So here we've got a couple different graphs. We've got the graph of y equals e to the x, and we have the graph of y equals natural log of x. Basically, natural log of x is the log base e. Okay? As a natural logarithm. And e to the x and natural log of x are inverses of each other. Cool? Awesome. Alrighty, so natural log, we use that a lot, so it gets its own little special thing, right? Instead of just log base e and we write that every time, nah, it's going to be ln, and we'll use it. It'll be awesome. Big thing to note, these guys are inverses of each other, meaning natural log and e undo one another, okay? So speaking of the natural logs and that they undo one another, if you take the natural log of e to the x like we have down here, I'm just going to be left with x. And if I take e and raise it to the natural log of x, I'm going to get x. So these cancel out and these cancel out. You can't have anything between the natural log and the e and vice versa. And we'll see some examples where that does occur and how to deal with it. Now, all of our rules still apply to natural logs that apply to regular logs, which is super awesome. For example, over here on the right-hand side, I can bring this 5 right here up to my 2, so I'd get 2 to the 5th, which is 32. Which is what we see, 2 to the 5th here, which is 32. And since it's subtraction, I can write it as division. So I end up with natural log of 8. And I could evaluate that if I wanted to, but that would just basically be condensing it right there, writing it as a single log. Cool? So again, all of them are the same. Same rules still apply. It just says natural log. It's kind of like if I gave you log base 4 or log base 5 or log base 10 and asked you to simplify, all the rules are still the same. So let's try a couple here. If I bring this 3 up to the exponent and bring this 2 up to my exponent, I'm going to have natural log of x cubed plus natural log of xy squared. And you could distribute that squared into the x and the y. So I'm going to have natural log of x cubed plus natural log of x squared y squared. And then I can put them together. Since it's addition, it becomes multiplication. So I'm going to have x cubed, x squared, y squared, all multiplied together. So really what I end up with is natural log of x to the 5th, y squared. Once I condense it all. Same rules as logs. Just one less letter. How great is that? Okay. The next one. Same idea. Boom. That goes up. So I get natural log of x to the 5th. And then I have minus natural log of y plus natural log of 5. So when I put these all together, it's going to be natural log, and I'm just basically going to set up a nice fraction here. I'm going to have x to the 5th. And then since I'm subtracting natural log of y, it's dividing by y. And then since I'm adding the 5, it's like a 5 times x to the 5th. All right, and I like to write the coefficient out in front. Sorry, that was a little bit sloppy. Let's rewrite that nicer. 5x to the 5th over y. Nice. Cool. That was fun. That was so fun. All right. Well done, guys. Common mistake here. Accidentally putting this in the denominator since we had subtraction here. This subtraction isn't applied to this natural log of 5. If I had parentheses, then it would get distributed to both, and yes, I would be dividing by 5, but because this is addition and there's, the subtraction doesn't apply to it, this stays up in the numerator as we see here.